So what about volume problems? Well, hopefully from the graphing activity that you did, you see that volume also has its own kind of issues we need to think about when we're talking about scaling up volume, right, or scaling down volume. So we need a new formula, not terribly new, and it shouldn't be very surprising either. Because volume happens in 3 dimensions, right? Volume problems are cubic problems. Then we need to consider all 3 dimensions for our scale factors. So these are going to present themselves in questions on your provincial exam next year. So if you are going to, let's say you're working on a construction project and you want to, you're making a tabletop and you decide that you want to make the tabletop 2 times bigger, right? Or you want to make it twice as long and twice as wide. Then what's the new area, what's the new amount of material you're going to need compared to the original tabletop? Or what if you're filling a pool and your neighbor is filling a pool that has dimensions that are, you know, twice as big as your pool? How much more water are they going to need to put in their pool? Turns out they're not going to put 2 times as much water in, right? They're going to put 2 times as much water in for the length, 2 times as much for the width, and 2 times as much for the height. So we've got to think about these things in 3 dimensions. So our work this year is kind of based around this K formula and how when we're talking about volume, we need to use K cubed. And these are going to work out very similar to our K-squared problems, which is why I've kind of put them into one lesson here. So let's take a look at this example problem in our notes. Smaller tank in the photograph has a capacity of 1,400 cubic meters, and the larger tank has a capacity of. So capacity is a volume problem. Okay, volume and capacity are pretty much the same for our purposes. Volume technically is how much space something takes up, and capacity technically is how much an object can hold. But for our purposes, that's pretty much the same thing. So capacity is a volume problem, and also that meters cubed should be a pretty big clue that we're dealing with volume. All right. During the refining process, both tanks are filled with oil from a pumping station at the same rate. How many times longer will it take to fill the larger tank than the smaller tank? Okay, so what we want to know is we want to know how many times bigger is this volume than this volume here. So let's use our formula. K cubed equals new volume over original volume. Okay, and because we're just dealing with filling it, we actually want to figure out what K cubed is. That's what we're solving for. So our new volume is this bigger tank, 4,725 cubic meters over our original, which is 1,400 cubic meters. And when you put that division into your calculator, you get 3.375. Okay, so that means it'll take 3.375 times longer to fill the larger tank. Okay, oh, that's messy, sorry. But that's how we can use that K cubed, right? It's just kind of, it's that comparison of the volumes or the capacities. If you flip over to the next page, the question we have here is how many times greater is the radius of the larger tank than the radius of the smaller tank? So the radius is a one-dimensional measurement, right? So, well, that's very blurry, sorry. We'll fix that, hopefully. There we go, sorry. So when we're talking about the radius, what we want to know is K, right? So K describes the scale factor on a one-dimensional scale. K cubed is the scale factor on a three-dimensional scale, right? Volume. So what we want to do very easily is, if we know that K cubed equals 3.375, we want to know what K is. So we're going to cube root both sides. So how you do this in your calculator is going to look a little bit different for everyone's calculator. But for me, my cube root button is the shift of my square root button. So I just go shift and then my square root button, and then this is kind of what pops up on my display. And then I can put 3.375 in there. I can close the bracket if I need to. And then I get K equals 1.5. So for some of you, you might have to put 3.375 into your calculator and then press the cube root button. And some of you are going to have a hard time finding it, but I promise you have that button. And so kind of play around with it and make sure you know how to get that answer of 1.5. All right, what does that mean? It means that the radius of the new tank is 1.5 times bigger than the radius of the smaller tank. Okay, hopefully that makes sense. So you've got some independent practice that follows, and that's what you should kind of work on for the rest of this lesson. Okay, take care, guys.